this video, we will be going through the basics of electricity. The atom is the basic building block of everything we can see, and many things we can't see. All atoms consist of neutrons, protons, and electrons. The number of electrons and protons in an atom can differ. When millions of atoms with the same amount of protons and electrons are put together, they will make up elements such as hydrogen, oxygen, carbon, and gold. Protons are positively charged subatomic particles that are located in the nucleus of an atom. Neutrons are particles with no charge and help stabilize the nucleus of an atom where it is also located. Electrons are negatively charged particles that orbit the nucleus. These orbits are called valence rings and are limited to the amount of electrons they can hold. In most cases, an atom can have several valence rings. The atom is held together by three forces, one of which is electromagnetic force. This is the positive charge of the protons attracting the negative charge of the electrons. If the electron moves from one atom to another, there will be an imbalance in the first atom and will cause the first atom to be positively charged. When this happens, the atom will take an electron from another nearby atom. This reaction will continue until all the atoms have the correct amount of electrons. We can create a flow of electrons when a large number of them are pushed across a group of atoms. This is called electric current. Development of electromotive force. In a car, this is created in three ways: chemical reaction, mechanical reaction, and crystal deformation. Chemical reactions are created in a car's battery, the remote or key fob's battery, and in the oxygen sensor. Mechanical generation is created in the alternator, the ABS sensors, the ignition coil, and the crankshaft position sensor. Crystal deformation is created in the knock sensor and map sensors. This is how easily an electron can be pushed from one atom to another and varies depending on the material. The number of electrons in a valence ring determines the amount of resistance the material will have. In our example, we have two valence rings. One has 8 electrons and the other has 2 electrons. The one that has 8 electrons will have a stronger force than the one that has 1 electron. When it comes to circuits, materials are divided into 3 categories: conductors, insulators, and semiconductors. Conductors will have 3 or less electrons in their outer valence, such as copper or iron. Insulators will have 6 or more valence electrons, and they will not flow at all through these materials. Semiconductors will have 4 or 5 valence electrons. These will appear in materials that are usually custom made for electronics. Measuring electrical potential. By measuring physical characteristics of electricity, we have a better understanding of how to control it. The more electrons we remove, the stronger the force will be for an atom to get back to the state of no charge, or equilibrium. We can provide a path for the atoms to regain their electrons, and they will flow back because of the imbalance of electric charge. This is called electromotive force, or voltage, and it is measured in volts. In any voltage supply, the energy coming from it will separate into the positive and negative charges in the conducting substance. One terminal of the supply will have the excess of electrons and the other will have the shortage of electrons. Units of voltage. In any vehicle, voltage will vary from 1/1000th of a volt to tens of thousands of volts, such as an ignition, for example. This is why we use prefixes in measuring voltage. For example, 1 millivolt is 0.00 of a volt, 1 kilovolt is 1000 volts, and 1 megavolt is 1,000,000 volts. Any power supply will have the voltage indicated on it, such as 12 volts for most car batteries and 1.5 volts for an AA battery cell. Voltage is measured by connecting the 2 terminals of a voltmeter or multimeter across the component you want to know the voltage of. Measuring electric flow. This is the movement of electrons back to positively charged atoms and is called current, represented in an equation with an I. This is where all the work in the circuit takes place and is measured in ampere or amps. We can measure the current in a circuit with an ammeter or a multimeter. Unlike the voltmeter, we must connect the ammeter in series and not in parallel. Measuring current in a vehicle's circuits can vary quite a lot, and again we will need to use prefixes. 1 microamp is 0.00001 amps. A milliamp is 0.001, and 1 amp is just 1 amp. Measuring electrical resistance. When electrons flow through a conductor, the flow is hindered. This hindrance is called resistance. It is measured in ohms, with an ohmmeter or again with a multimeter set to ohms. Every component in a circuit has resistance, including the wires. The prefixes are used as follows. 1 milliohm is 0.000001. 1 ohm is 1 ohm. 1 kilo ohm is 1000 ohms, and a mega ohm is 1 million ohms. Resistance can vary depending on the type of conductor used. For example, a copper wire has lower resistance than an ignition wire because it has more free electrons. Other influences on the resistance are the length of the conductor, the width of the conductor, and the temperature of the conductor. All these are taken into consideration when designing electrical systems. Electrical circuits. In order to operate, any electric circuit must have 3 things: a power supply, a conductor, and a load such as a bulb or monitor. If there is a fault in the circuit, we can determine where the fault is by understanding a few basic laws about how electricity behaves, such as Ohm's law. In 1826, George Simon Ohm discovered that there was a relationship between voltage, current, and resistance. As he increased the voltage in a circuit, the amperage was also increased. The law named after him states that it takes 1 volt of force to push 1 amp of electricity through 1 ohm of resistance. We can calculate any of the variables like this. Voltage equals current times resistance. Current equals voltage divided by resistance. And resistance equals voltage divided by current. Ohm's law in a series circuit. When there is only one path in a circuit for a current to flow, this is called a series circuit. And when there is more than one component placed in a series, the same current will flow through all the components. When there are multiple resistors in series, the total resistance is simply the sum of the individual resistances. The total voltage supplied will be divided among the individual resistors. If the total resistance and voltage in a circuit is known, we can use this to calculate how much voltage each resistor will use. This amount used is called voltage drop. Well, let's do the math. First, we find our total circuit resistance. In this case, 1500 plus 1500 plus 1500. Then we use Ohm's law to find the amount of current in the circuit. AT equals VT divided by RT. In this case, 12 volts divided by 140 ohms, and that equals a 375th of an amp. Finally, multiply the amperage passing through each resistor to find its voltage drop. Remember, we have to do this for each resistor in the circuit. V1 equals AT times R1. That equals 1 over 375 times 1500. And the result is 4 volts. We can check our answer by adding the individual voltages together. They should equal the total circuit voltage. In this case, it is V equals V1 plus V2 plus V3, and the result is of course 12 volts. Laws governing parallel circuits. In this case, there is more than one path that current can flow through. In the example we have here, there are 2 resistors. One is 22 ohms and the other is 100 ohms. When voltage across each is measured, it will be the same because they are supplied with the same amount of voltage. When measuring the current flow, however, we will see that the total current will be larger than the 2 individual current flows, but will be equal to the sum of the current flows. current through the smaller resistor will be larger than current through the larger resistor. Here is another example. In this case, we have 4 resistors: 10,000 ohm, 1000 ohm, 100 ohm, and 22 ohm resistors, each in a parallel branch. The total resistance will be smaller than the smallest individual resistance. In this case, the total resistance is called equivalent resistance. In our case, the formula to calculate resistance in parallel is 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Our final result will be RT equals 17.68 ohms. Something to remember: when an electric device is connected to an existing circuit in a car, the total resistance will decrease and therefore the amperage will be increased. This can cause damage to the car's electrical system and could possibly even start a fire. Mixed circuits. In its simplest form, there are 2 ways this can be represented. We can find the equivalent resistance of the whole circuit by firstly calculating the resistance in the parallel circuit, then treating it like a series circuit by adding the remaining resistance. Here is an example of that. RE equals 1 over R2 plus 1 over R3, 1 over 47 plus 1 over 100, and the final result is 31.97. Now to calculate the total resistance, we just add that, and then we get our final result of 361.97. In the second example, we simply add the 2 resistors in series and then calculate the equivalent resistance after. Electric power. Here we have an example of a dam turbine. It will generate more power when the water has further to go from the dam and when more water flows through the turbine. Likewise, in any electric circuit, we will have more power when there is a higher voltage and a higher current flow. We can calculate it using this equation. P equals V times I, where P equals power, and this is measured in watts. From here we can combine it with the equation from Ohm's law. P equals V2 over R, and thereby P equals I2 times R. We can therefore calculate power from the current and resistance, or voltage and resistance. Wattage is an important measurement in various vehicle components, for example, light bulbs. Last calculation. What is the current used by 2 21 watt indicator bulbs? Here we can calculate this by saying I equals 42 watts over 12 volts, and the answer is 3.5 amps. Please like and subscribe. Keep on the lookout for more upcoming videos.